This screencast will walk through one way we can use Microsoft Excel in a math class to encourage students to make predictions about how different constants might affect a population growth model. And this exploration could occur after the students have been introduced to general exponential growth model. So they would already know the general equation P equals P naught times e to the kt, and they would know what each constant actually represents. So they would know that P naught is the initial population, and they would know that K is the rate constant. And so to actually begin this, we can open Excel, which is already open here, and we can go to the sheet that I have created here. And at the top, I show the primary equation that we're working with to ensure that the students are reminded of the root of this activity. We're trying to explore this equation. I've highlighted the cells yellow, which the students will be able to modify. I don't want the students to touch any other cells in this worksheet. And I've also identified what each constant represents so that students are reminded of the real-world applicability of these variables. And the initial setup of this spreadsheet is actually very crucial. I've put in a variety of time values here, and the corresponding population variables are calculated based on each time and the values of P naught and K that are put in. In addition, there's a graph here to visually represent the data. And so on the x-axis, we have time. And so at different times, we have all the different populations. And so students can experiment. They can type in 200 for the initial population and see how the graph changes. They can change the rate constant to 0.5 and see how that affects the graph. We can change the rate constant to 0.02 and see how that affects the graph. And so students are free to explore here and then come to conclusions. But really, as great as this technology tool is, it's only as good as the questions that we use to guide the students. It's important to have a good set of questions that will push the students to really explore this and to draw the right conclusions. So some questions we might start by asking students to set both values and then predict the population at a certain time. So for example, if the initial population is 100 and the rate constant is 0.08, we can ask them, what is the population at time 80? And so they can look at the graph and they can actually come up with a value here. And we can ask them to explore different P naught values and K values. Then we might ask questions like, keep the initial population at 100 and modify the rate constant, 0.03, 0.04, 0.05, and so students can make observations about what's happening to the graph. And then finally, we can even ask deeper questions, such as which parameter has a greater impact on the population in the long run? Finally, we can really get to the prediction questions that are the deepest, and perhaps we can say something like, without entering the value k equals 1000, describe what you think might happen to the graph. So based on the previous questions and seeing what the graph has done in the past cases, students can make a prediction about the importance of the K value. And so this activity really has a lot of potential, but again, it's really as good as the questions that are used to allow the students to investigate deeply.